Welcome back to the Deep Dive. Today, we're taking a look at the very cutting edge of large language models. We're focusing on a core problem that seems to plague even the best AI. What happens when you give a model too much context?
Exactly. I mean, that's the mission today, to unpack this paradox. These massive LLMs, they're built to handle millions of tokens. It sounds like infinite memory. But the research, it shows they often take in, far more text than they can reliably use.
So we're giving them these huge digital libraries to read, but they're getting lost in the stacks. The core tension here, then, it really boils down to resources, right? How do you spend that precious inference compute when the input is just gargantuan?
Right. And well, traditionally, the answer has been to just throw more compute at it during inference, usually by getting the model to generate its own chain of thought, what we call thinking tokens. The model is sort of talking to itself to reason things out.
And that's the strategy that's failing when the context gets really, really big, correct?
Yeah. It is. The paper is very clear that these strategies show rapidly diminishing returns. They just completely fail at long context. The model can write pages of internal notes and still miss the key fact buried 50,000 tokens ago.
So why does that happen? We've heard the term score dilution thrown around. Can you, break that down for us? Why does the architecture struggle?
It's a fundamental failure of what's called static self-attention. Think of it like this. The model gives an attention score, like a little weight, to every single token in that massive input. But when you have millions of tokens, and most are irrelevant, the weight for the few critical ones gets statistically washed out, diluted.
Okay, so the important signal gets lost in all the noise.
Precisely. It can't reliably retrieve what it needs anymore. It's like looking for a needle, not in a haystack, but in a whole field of haystacks.
That really puts it in perspective. So you
Huh?
can't just scale your way out of the problem. And this is where it gets interesting, because the paper's takeaway is that we need to completely change how we use our compute time.
We need to change what that compute is for. So instead of generating more of that internal text, those thinking tokens, the authors propose a really simple-sounding solution called test-time training, TTT for short. It uses targeted gradient updates on the given context.
Wait, hang on. Training at test time, that sounds completely counterintuitive. Are we talking about doing a tiny, context-specific fine-tuning session right in the middle of a task? What's actually being updated?
That's exactly the paradigm shift. It's not a permanent update. It's a tiny momentary optimization. You use a little bit of that inference compute to run gradient updates, to adjust the model's weights just enough to make it focus on the information in this specific context right before it answers.
And that adjustment is designed specifically to fight that score dilution problem we talked about.
Correct. And the research shows this approach, quote, provably overcomes the limitations of static self-attention. The efficiency part is key here. For long context, that small burst of training is a much better use of compute than generating tons of thinking tokens.
Okay, so the proof must be in the numbers. I mean, how big were these performance gains in practice?
Oh, they were consistently large. If you look at the Qwen 3.4b model specifically, the performance leaps were huge. It averaged, I think, 12.6 and 14.1 percentage point improvements on subsets of the LongBench and ZeroScrolls benchmarks.
Wow. That is a significant jump.
It's a huge jump. It really validates that decision to reallocate compute from generation to context optimization.
So what's the big picture here? The fundamental shift is we're moving away from asking the model to sort of think out loud, and instead we're optimizing its actual understanding of the specific text you just gave it.
Yeah. It suggests the future isn't just about how much context we can give these models, but how efficiently we can force them to integrate it when it matters.
That leaves a really interesting final thought, doesn't it? If a tiny, targeted update to the model's memory, right at the moment of use, can create such massive gains, what does that mean for the future of customized AI? We might be moving into an era where models learn just what they need to know for that one task, where the quality of how they integrate context is way more valuable than the sheer quantity. Something for all of us to think about.
Definitely.
Thanks for joining us for the Deep Dive. We'll see you next time.